Sometimes you want to draw a parallel line with triangles. And to do this, you place a triangle along the line, place the other triangle next to it, and then you can slide the triangles, holding one fixed, and draw parallel lines. Now here the triangle is moving sideways as it's moving up. You may want a parallel line straight up there. Way to do that is to switch the triangles around. Again, line it up on your line and you can slide one and you have parallel lines. Adding vectors to the parallelogram rule. Again, you have triangles, and we saw how to draw parallel lines. So what we want to do is take one of the vectors and move up to the head of the other vector and draw the parallel line. And likewise, rotate things around and draw a parallel line to the other vector through the head. Didn't draw it long enough, so you can extend it. Find out where they join, and the sum vector is through that point. To add two vectors with the triangle rule, you can use triangles again and drawing parallel lines. And what you want to do is you want to take one vector and put it up to the other vector, move it from its tail to its head, or the pointy end is the head. We want to copy that vector. The vector has magnitude and direction. We can get the direction by doing a parallel line, but we still need the magnitude. So I'm going to use these, and we got our point here. Oops. And then the vector again is from the root to this tip point. And this vector is the sum of these two vectors. Adding by components. To add two vectors by components, the first thing you need to do is pick an axis. I'm going to pick an x-axis and a y-axis. These axes should be perpendicular to each other. That is, this is a 90-degree corner here. Now the first thing we need to do is to break the A vector into components. And to do that, we use our 90 degrees here and line up the end and project that down to the axis. So on our x-axis, we have 4 units. And on our y-axis, for A, we have 6 units. And we do the same thing with B, the other vector, project its values to the axis. This is 10 for B, and likewise 5. Now what we want to do is add the vectors that are on the same axis. Two vectors pointed in the same direction, you just add their magnitudes. So we take our magnitude of our A vector and add it to our magnitude of our B vector in the x direction. Then we get 14. And likewise, we can add the two vectors, B to A, and we're at 11. Then we take these two coordinates, or these two vectors, the y vector and the x vector, and add them. It's really with our parallelogram rule. And we have our sum vector. Here. Another way you can do it, like I said, is you can pick your axis. So we could pick our axis to align with one of the vectors. So let's just call this x prime. And likewise, we have another axis we'll call y prime. And since the b vector is on the x-axis, its projection's already done onto x, and it has 0 on the y vector. So we just project the a vector onto the x-axis, and we project it onto the y-axis. Then we add the components together in the same direction by moving the tail to the head. And we get that in the new x prime vector. And this is our y prime vector. Then we merely, again, use the parallelogram rule and add our x prime vector and our y prime vector, and we should get the same point. My drawing isn't that good, so it's off a little bit. Thank you.